Hello, I'm Kavya from 11B, and today, me along with my group, Simran, Tavishi, Minakshi, and Ananya, are going to discuss conic sections with the help of a carrot. There are four main conic sections we're going to talk about today. One is circle, the second one is ellipse, parabola, and hyperbola. I'm going to be describing each conic section in brief. My friends will describe it in detail. As I said, the first part is a circle. When we cut a cone like this horizontally, we get this cross section, and this forms a circle. The second one, as I said, was ellipse. Now we know this is a cone. If we pass a plane diagonally to this cone, we get something like this, and this shape formed here is an ellipse. The third conic section is parabola. When a plane is passed this way through a carrot, which is like this, it forms a curve. And this curve you see here is a parabola. The last conic section we're going to talk about today is the hyperbola, which is kind of similar to the parabola but not exactly. We're going to cut the carrot vertically downwards. We get something like this, which is a huge curve. This is known as the hyperbola. Now over to Ananya to discuss each conic section in detail. Thank you.
Let us start with the first conic section, the circle, a figure that we see often in our daily lives. The circle is formed by the collection of all the points in a plane which are equidistant from a fixed point in the same plane. This fixed point is called as the center of the circle, and the distance of any point on the circumference from the center of the circle is called as the radius of the circle. The circumference of the circle is its perimeter, and its value is given by the formula 2 pi r, while the area of the circle is given by the formula pi r square, where r is the radius of the circle. The general equation of a circle is of the form x minus h whole square plus y minus k whole square is equal to r square, where r is the radius of the circle and h comma k are the coordinates of the center of the circle. Another form of the general equation of the circle r is x square plus y square plus 2gx plus 2fy plus c is equal to 0, where the radius squared is equal to g square plus f square minus c, and the coordinates of the center of the circle are negative g comma negative f. Now let's see how to make a circle. This carrot is roughly in the shape of a cone, and the knife represents a plane. When the knife makes a cut perpendicular to the central axis of the carrot, the cross section formed is in the shape of a circle. Here we can see the shape of a circle. Now we move on to the next conic section. Thank you.
Now we are going to talk about the next conic section, ellipse. An ellipse is a set of all points in a plane, the sum of whose distance from two fixed points in the plane is a constant. The two fixed points are known as the foci of the ellipse. If we have a line joining the foci, it is known as the major axis of the ellipse. The center point of the major axis is known as the center of the ellipse. A line passing through the center and also perpendicular to the major axis is known as the minor axis. The end points of the major axis are called the vertices. We denote the length of the major axis as 2a and the length of the minor axis as 2b. For a point P x, y, the equation of the ellipse is given by x square by a square plus y square by b square equal to 1, in which case the major axis is the x-axis. When the major axis is the y-axis, the ellipse equation is given by x square by b square plus y square by a square equal to 1. In a cone, elliptical conic section is formed when the angle made by the intersecting plane with the vertical axis of the cone is greater than that of the vertex angle and lesser than 90 degrees. Now let me demonstrate how an elliptical conic section can be obtained. Taking this caret as a cone, this is the vertex angle formed. Now I'll be cutting a conic section. Now we can see the cross section forms the shape of an ellipse. That's it for ellipse. Next, Simran will be explaining the next conic section.
The next conic section we'll be discussing is the parabola. A parabola is a set of all points that is equidistant from a fixed point and a fixed line in a plane. This fixed point is known as the focus and it does not lie on the line, and the fixed line is known as the directrix.
We will now see how to obtain the parabola conic section using a caret as a right cylindrical cone. This knife will represent a plane which intersects the nap of the cone. The angle made by the plane to the vertical axis must be exactly equal to the vertex angle to obtain this conic section. Now let us cut along this line to observe the shape formed. We notice that we get an open curve which is known as the parabola.
Now let us discuss the standard equations for a parabola. We are going to be taking the origin as the vertex of this parabola and the axis of symmetry to be either along the x-axis or the y-axis. Taking this as our curve for the parabola, there can be 4 possible orientations. We can see that it can be like this, facing upwards, facing either side, or even facing downwards. First, let's talk about the equations for the parabolas which have their line of symmetry along the x-axis. In the first case, the focus lies at a point a, 0 and the curve extends indefinitely into the second and third quadrant. In this case, the equation for the parabola is given by y square is equal to 4ax. In the other case, when the parabola faces the other side, the focus is at a point minus a, 0, and in this case, the curve extends indefinitely into the first and fourth quadrants. Here, the equation is given by y square is equal to minus 4ax. When the line of symmetry of the parabola lies along the y-axis and the focus lies at a point 0, a, the curve extends indefinitely into the first and second quadrants, and the equation of the parabola takes the form x square is equal to 4ay. Similarly, when the point of focus lies at 0, minus a and the curve extends indefinitely into the third and fourth quadrants, the equation of the parabola takes the form x square is equal to minus 4ay. Another term associated with the parabola is the lattice rectum. The lattice rectum of a parabola is a line segment which passes through the focus, is perpendicular to the axis of the parabola, and whose endpoints lie on the parabola. Mathematically, the length of the lattice rectum is equal to 4a. Now, Tavishi will be going over the next conic section.
To be talking about hyperbolas. The shape obtained when we take a vertical cross-section of a double cone joined at the vertex is called a hyperbola. In this case, these are the double cones joined at the vertex, and this cross-section, vertical cross-section, is called the hyperbola. It is by definition the set of all the points in a plane, the difference of whose distances from 2 fixed points in a plane is a constant. Now I'll explain the parts of the hyperbola. The 2 points are called the foci. The midpoint of the line segment joining the foci is called the center of the hyperbola. The line through the foci is called the transverse axis. The line through the center and perpendicular to the transverse axis is called the conjugate axis. The line segment perpendicular to the transverse axis through any of the foci whose endpoints lie in the hyperbola is called the lattice rectum of the hyperbola. Thank you.